हेलो गाइस, so आज हम प्रॉब्लम नंबर 2369 चेक इफ देयर इज अ वैलिड पार्टीशन फॉर द array सॉल्व करेंगे. आई हैव ऑलरेडी सॉल्व दिस प्रॉब्लम. इट इज a medium level problem on LeetCode. So in this problem you are given a zero indexed integer array nums. You have to partition the array into one or more contiguous subarrays. We call a partition of the array valid if each of the obtained subarrays satisfies one if each of the obtained ठीक है subarrays satisfies one of the following conditions. The subarray consists of exactly two equal elements जैसे कि 2 2 like 2 2. The subarray consists of exactly three equal elements like 4 4 4. I'm talking about each subarray which will be formed, and the subarray consists of exactly three consecutive increasing elements. That is, the difference between adjacent elements has to be 1. So 3 4 5 is good, but the subarray 1 3 5 or 2 3 8 is not. So if we can do this, if we can make our subarray, given subarray, into these valid subarrays, then we have to return true, else we have to return false. So for example, we are given subarray 4 4 4 and then 5 and then 6. So we are given this as subarray, right? So can we form this into valid subarray groups? So we can see that if we divide it by 2, one group will be this and the other group will be this. So the answer will be true for this case because there are two exactly same elements and there are exactly three elements in increasing order by one. Makes sense. Another example you are given is triple one two, one one one, and then two. So in this case we can see that, so the thought process of solving this question will be to first check any of the three conditions, right? I'm over here. Let's see, for these two elements, can I divide the subarray? Yes, I can divide the subarray into two. In can I divide? I can make a subarray here of two elements which are of which are equal, right? So basically, 1 1 is a valid. Right now, I'm left with 1 2. But is 1 2 valid? So no, it is not valid. Okay, then I skip. Then I move on to the next attempt, which is triple one, considering 1 1 1 as the initial subarray. So now we are left with only 2. So this is valid, but I'm left with only 2. So this whole seems to be invalid, right? For now there is another, because if I'm considering another three elements, for example, the third case would be 1 1 1, right? But the third case is that they have to be in increasing order, which these three elements are not. So we can say that this has to be false, right? So the idea that we are gonna use to solve this problem is basically take a look at the subarray. I'll undo some of the stuff so it becomes clear. Just a second, guys, sorry. Yeah. So the idea becomes that we'll first consider that I'm using when we are thinking of doing this recursively. So the I will solve the DP approach, but in order to understand DP, I think it is important to maybe know recursive, even though I think that even without recursion, one can understand DP solution of this question pretty directly and make sense of it, that why it's happening, right? But let's go with recursive solution. And even using recursive, one can understand memoization solution. So I think that's another important advantage of understanding recursive solution. So according to recursive solution, what we'll do is we'll create an I pointer over here. We'll see if from the starting point to, we'll first consider, okay, we'll consider three cases for every um for the starting point. So there are three cases, right? One one, two elements, three elements, and three elements in increasing order. Then we'll see all these three cases for again, for two elements, then three elements, checking three elements, and then three elements. For example, if we are over here, we can see that two elements, we can form two elements over here. This means that this state, this function will now move the I pointer, the index, from here to here, because this part is already valid, we know that. Then what will happen? Then we'll again move to, then it will come over here and check if we can again divide the next part of this into these three, in any of these three cases, we can see that 1, 2, not 3, there are no more than 3 elements, and so we can't solve this. So right, so then this will return false over here. Right, now we come on to the case where we have 3 elements. Yes, there are 3 elements which are same in the same values. So we are again go over 3, 3, and then 3 increasing. We can see that so for this case our I pointer was over here, right? Initially when I was at 0, but when it comes, initially I was here at 0, but when it is through it is, if it's going down, then the I pointer will move to actually I plus 3. So it will go from here to here, and we can see that we can't divide this subarray into any more ways because the length is all, because the length is less than minimum of 2 comma 3. Okay, making sense. So this will also return false. So this will return false, and if this is return false, right, now we are going to see if 3 increasing, so we can see that 3 increasing will directly return false. So we can, if we can't break the complete subarray into any of these, we can't do it by, we can't break it by using the 2, 3, we can't form the subarray into any of these forms, so the answer, the complete end will be false. Let's solve this for another case, I think for the case where it is happening. So which is 4, 4, 4, 5, 6. So let's do it for this case. I think this will be better to explain. So actually we can see we are gonna start our I equal to 0 from here. Gonna run over 3 cases, 2, 3, and then 3 in increasing order. So we can see that 2 is making sense, so this one is definitely okay. We're gonna move then again to 2, 3, and then 3 increasing. We can see that here this part is not making sense, this is not happening, but this part 4, 5, 6 is happening. So here when I'm going down, I can see that I'm 2, 3, and 3 increasing, but right now here I'm at the end of the array, right? I have added 3 to it, so I'm at the end of the array, and this is a base case. If we reach the end of the array, that means the sub array can be divided. Okay, so since it can be divided, so clearly this function will return true over here. So if any of the following returns true, right, if we can divide in any of the ways, and if any of the sub order, so that means the whole function should return true, so that means this will return true, this will return true, and then this will return true. So that's how this one will work. Okay, so this was about the recursive problem. I think you've understood what I was trying to suggest, what I was trying to implement. Now let's move on to the DP solution, which is I think easier to understand. It is like pretty basic to understand the solution. So what we are gonna do is we're gonna divide this up. We are gonna iterate every element, and we are gonna consider that from the starting to that index, we have to we have to see if the sub array is good, is valid or invalid. For example, we are at index 0. So I'm going to start my index from here, and I'm going to iterate every element. So when I'm at here, I can see that dp of I. So I'll store the result. So dp of I will store a boolean value which will be true or false. Okay. So what exactly dp of I will mean? dp of I will mean that the sub array starting from 0 to the ith index, is that a valid subarray? That's all it says. If it is true, that means from starting from index 0 to I, the subarray is valid. It means it can be divided. It means that that array can be divided. If it is false, that means it can't be divided. Simple as that. So when I'm at index 0, I can see that it is not a valid subarray because of obvious reasons, so it will be false. When it is at index 1, I can see that from 0 to 1, the subarray is actually valid because these are same elements, so this will be 4. Now when I'm over here, I can see that this again is valid because these three are elements that are in same, that are of equal value, case 2. So this is true. But when I'm at over 5, I can see that, so there are now when I'm at index 5, this there when I'm at index actually 3, when I'm at I equal to this is where the logic or the crux of the question begins to unwrap is that we have to look we have to look previous values. For example, we need to see if dp of I minus 2 is true. If this value is true and our and the subarray of I and I minus 1 is following case 1 where two elements are equal, or we need to see if dp of I minus 3 is true, or either these three elements I minus 1 and I minus 2 are equal, or they are increasing in consecutive order by 1. So if these two things are consecutively, if any of these two things are valid or true, then that means this will form a valid subarray. I hope it is making sense. For example, I'll show you. Now I'm at index. Now this was actually index 3, right? Index 3. I can see that dp of, let's go over this. Let's go to, let's see if these two elements are equal. No, they are not equal. Are so then we'll check if these three elements are equal. No, these three elements are not equal. Are they increasing in order? No, they are not in increasing order. So this will be 0. Now let's go over here. Now we are moving to index 4. So I equal to 4. Now we need to check if these two elements are equal. No, they are not equal. Are these three elements are equal? I equal to 2, I equal to 3, or I equal to 4. We can see no, they are not equal. But are they increasing in order? Yes, these three are increasing in order by 1. So that means the answer to this will be, if we can see that this will form a valid subarray. So the answer depends, will dp of I, dp of 1. So if this is true, which means that if this can be subdivided into valid, then this can also be divided as a whole can be divided. But if this cannot, then simply this also cannot. So we can see that dp of 1 is actually 1. So this is where our answer comes, and this is what will return for the whole array. Yeah, that's pretty much it. Actually, I think I've understood, explained the whole problem. Hopefully this made sense. Guys, please also like, share, and comment. I'll write the code now, but please consider giving comments, likes, or shares so that I know where to improve and I'll gain some popularity. Lol. So I'll start with the. So I'll code only the a tabulation solution for this problem because I think that will be enough. So I'll start with creating a dp vector which is of size nums.size only, and I'm gonna first start with, oh wait, it should be a boolean, not a true, because we are gonna store 0 or 1, so it should be like this. I'm gonna store it with false value. Now now we can see that minimum length is actually 2, but let's start with dp of 0. So dp of 0, which means the length is, basically what it means is that I'm at the first element and the first element has to be 0, right? Now when I'm at dp at 1, so that means I'm at the second element. Now this can be true, right? If both the two previous, if the 0th element and the 1th element are equal. So this can be simply written as nums of 0 is equal to nums of 1. If this is true, this will also be true. If it's false, then we can't break it down. Now let's go with another base case that will, now before doing this, let's see if n is equal to 2, right? Then I will simply return dp of 1. Makes sense? Now, because there might be a case here, n is 2. So if n is 2, I don't need to go travel down and make an error on index range out of bound or something like that. So you'll see why it's happening, because I'm writing another base case of dp2 when I'm at the third element. So when I'm at the third element, there are actually three cases to be we need to consider: if these three elements are equal, if they are increasing order, or if if only those two elements are equal, right? If the Well, actually it depends on three elements itself. So let's see. So actually now I'll just come over here and we need to check if those three elements are equal or are increasing order. So I'll write over here, if nums of 0 is equal to nums of 1 and nums of 1 is equal to nums of 2. If this is the case, then I want it to be true. Or there's another case. If nums of 0 is equal to nums of 1 minus 1, and nums, let's write it, nums of 1 is equal to nums of 2 minus 1. I'll short this up so that it all comes into straight line. Yeah. If this is the case, then only our dp of 2 will be true, otherwise it will be false. Now, now we are coming on to now we're gonna run a loop over all the elements. Okay, my laptop's battery is low. If now we're gonna iterate over the next elements, I is 3, I is less than nums dot size, and then I plus plus. If this is the case, right, then what I have to do is I need to go over dp of I. So what I will do is I need to check if the previous two elements are equal. If nums of I is equal to nums of I minus 1, and there's one more condition over here, which is if dp of I minus 2 is also true, right? This is making sense, right? Because these two conditions have to be same to make a valid subarray. This has to be one of the conditions. If this is the case, then dp of I can just write it as blankly true, right? Else, another case which comes is if I can write else if statement also. Wait, it's better to write it if only. It will make sense. If dp of I minus 3 is true, okay, and now there are two cases that we need to consider. If nums of 0, if wait, it should be nums of I is equal to nums of I minus 1, and nums of I is equal to nums of I minus 2. These two conditions. Or there's one more so this was the first condition, and the other condition was if nums of I is equal to nums of I minus 1 plus 1, or and wait, sorry, and nums of I is equal to nums of I minus 2 uh, and plus 2. If these two are the cases, then I will write dp of I is equal to true, right? And yeah, that's actually those two cases are the only cases which when we need to do this, and if it is not the case, then I will return true. I think I'm not gonna do actually let's do it. Actually, I wasn't thinking of doing dry run of the code, but I think it's good that I do dry run. Maybe some things, maybe there are errors that I can find out, or maybe not, but it actually increases the length of the video, so I wasn't reluctant to do that, but okay, let's do it. So now we are running the dry loop over here. This is our index input array. Let's see. So I'll write a dp index over here, right? Dp array, here it comes. So the first element is false, makes sense. The second element, these two are true. 0, nums of 0, this is true, so this will be 1. Moving on. Now we can come over here. This is not the case if nums of 0 is equal to nums of 1 and nums of 1 is equal to nums of true. So this is true and it's not gonna go over here. So this is okay. It's not gonna calculate this part. Now I'm coming over index 3 and I need to check this. So if I minus 2, dp of I minus 2 is true. So dp of I minus 2, which is minus 1 minus 2, this is true, okay. And nums of I is equal to nums of I minus 1. No, it's not the case, then it will be false. Then I'm not gonna go inside this loop, sorry. And if I minus 3 is true, no, this is also not true, so it's not gonna go, so it's gonna be 0 over here. Coming on to the last run. So if I minus 2 is true, yes, this is true, and nums of I is nums of I minus 1. No, this is not the case, so it's not gonna go inside this loop. Coming over here, I minus 3 is true, yes, and nums of I is equal to nums of I is equal to no, or it's gonna go over here. Right, I have written the yeah, and nums of I is equal to nums of I minus 1 plus 1 and nums of I is equal to nums of I minus 2 plus 2. Then it should be true. And oh wait, I'm returning dpfi. See, I told you I was gonna make a mistake somewhere. Nums dot size minus 1. Yeah, this is what I have to return. Let's run this. Okay, I think there's a bug in the whole shit. Oh my god. There's a whole bug over here. Oh my god. Actually, I've been facing this problem with Quietus for quite some time on Microsoft. I'll pause the video. Alright, sorry guys about that. There was something weird. Microsoft Edge. Let's run this code. This is the same code, I've just transferred it to. Oh, actually, there's not end defined. Okay, my bad, sorry. Nums.size, I meant end to be nums.size. Sorry about that. Yeah, see, both the test cases are passed over here. Let's enter this to see if all the test cases are passed, and there's been a wrong answer over here. Strange, strange, strange. I think I know where I'm making a mistake. I think I should not check over on this. I'll just maybe make sure it's like this. Sorry, dpfi is true. Then I'll continue maybe. I'll use this test case. Now let's run it. Yeah, actually there's something wrong with my code, which I don't know. This doesn't happen. I'll pause it.